problem with showing.
अरे हाँ, so
Maybe
please
just I will
restart.
join again.
हाँ, restart. एक बार आप फिर से ज्वाइन करेंगे, हो जाएगा मेरे ख्याल से, दिक्कत नहीं होगी. So I think we have 20 participants.
Yeah, good afternoon.
Your video is coming, sir. Yes.
Yeah.
Welcome, sir. So we have 38 participants from different parts of India. Some are from IITs, TISS, Allahabad University, Lucknow University. Some are joining late. We can wait for 1 or 2 minutes. By the time, at least major number of participants will join. So today we have NFHS session only in post-lunch session. So first, Professor L.K.Dwivedi will speak about understanding National Family Health Survey data. And after tea break, we will have Dr. Angan Sen Gupta from Amrita Vishwa Vidyapeetham, Bangalore. He will deal about the understanding health economics using National Family Health Survey data. So without wasting much time, I would like to first introduce Lakshmikant Dwivedi, sir. Professor Lakshmikant Dwivedi is currently professor in the Department of Survey, Research and Data Analytics in International Institute for Population Sciences, Mumbai. He did his master in MSc in Statistics from Banaras Hindu University and MPhil from in Population Studies from IIPS Mumbai, International Institute for Population Sciences, and PhD from IIPS Mumbai only. So he had taught in IIPS as a teacher in extramural studies. Further, he taught in Tata Institute of Mumbai Science, Tata Institute of Social Sciences, Mumbai, and then he is teaching from, I think, 2012 regularly at International Institute for Population Sciences. So he has more than 61 research papers on his name, and he is a really well-cited researcher in population studies, public health, fertility studies, and he has been principal investigator of National Family Health Survey 4 and 5 also, which has recently released the data set. Changes in household amenities and assets in India, census-based study, 2014, and midline rapid assessment, Swabhiman Women's Nutrition Demonstration Phase 1, and he has done survey, means led the survey in Bihar, Chhattisgarh, Odisha, funded by UNICEF. Then geospatial mapping of at village and ward level in UP, funded by IIPS Mumbai, which is an ongoing project. And no doubt, NFHS 6 is also being led by a team of researchers in which Professor L. Lakshmikant Dwivedi is principal investigator, along with other professors of IIPS. So he has also received postdoctoral fellowship through Erasmus Mundus Europe, Asia in 2012-13 batch. He was offered a visiting assistant professorship in Population Studies Unit, Indian Statistical Institute, Kolkata in 2012-14. He has been invited as a scholar in London School of Economics, Health and Social Care, in London School of Economics and Political Science, London during 2011. And today he will be dealing the NFHS thing, which is his own risk, means he's and principal investigator of that. So now I hand over to Professor Lakshmikant Dwivedi, sir. Sir, please, you can start, sir.
Yeah, thank you, Dr. Kunal. So I can share my slide now.
Yes, sir. Just there is a symbol of mic. So there is an upper arrow. When you click on upper arrow, it will allow you to share your complete screen.
Okay.
Open share tray लिखा रहेगा वहाँ पे. You can share your any window you can share.
Are you able to see my slides now?
And yeah, it has come now.
Now you are able to see.
Yes, you can do full screen share.
Okay, okay, okay. Thank you. Yeah. First of all,
Sir, your slide is again is not coming. I think you have to click on that and you have to set that. No, slide is not coming now.
now you are able
Yeah,
to see.
now it is coming. So you can do full screen presentation now.
Okay. Okay. Good afternoon, all of you, and uh, thanks to Dr. Kunal for inviting on this workshop. And personally, I am very much thankful that he has given the opportunity to speak on National Family Health Survey. Some of the in the next maybe 1.5 hours, we'll discuss some of the important findings of NFHS 5 along with what are the design of the survey and how the weight has been computed. So maybe briefly I will try to explain it. Maybe just I wanted to inform that one, uh, IPS has a funding, you have a funding and you can support for the workshop of analyzing the NFHS data also along with design and weight computation. So if any university like GB Pant or
Yes.
BHU, they can invite, so you can arrange 2 to 3 days workshop along with collaboration with the some institute. Then you can
Mhm.
maybe manage it in detail. You can discuss it. So here I will
Yes, sure,
try
sir.
to
It will
explain
be
it
good for us.
uh,
Definitely, sir.
in the next 1.5 hours, whatever the possible is there. So now, if you look at the NFHS, as I think most of you are aware about this, NFHS are conducted under the guidance of Ministry of Health and Family Welfare, and this data has been extensively used for evidence-based decision making. If you look at the in the 2005-6, the estimates of the HIV at that time, it was you are not aware what is the prevalence of HIV. Some are it is only making the guess. Some are thinking it is around 10%, might be 5%. But once NFHS 3 has been conducted, so it provides the estimates of the prevalence, and it is less than 1%, maybe around 0.24%. So then all the policy and program has been changed uh, since 2005-6. Otherwise, before that, the program and policy was completely different. And not only this one, maybe if you look at any program in the area of health sector, like conditional cash transfer or any other programs of NHM. So there, the NFHS data has been extensively used. And then whatever the definition you are taking in NFHS, it is comparable across all the 90 countries where the DHS has been conducted. So here, in other countries, it is DHS. In India, it is known as the NFHS, but it is almost comparable because you have questionnaire is standardized in such a way that the data set can be compared not only across the states of within India, but between country also one can compare the any other indicator. So generally for NFHS, you are using the most reliable and updated frame. But now you know that frame is too old because census has been conducted in the 2011. So using census 2011, you have you have conducted the NFHS 4 as well as NFHS 5. Maybe in NFHS 6, we are trying to get the frame from NSSO. Maybe some updated frame will be used. And then IPS has been the nodal agency for all rounds of NFHS. With we are receiving the technical support from ICF, USAID, and then the main aim of this survey is not only to generate the data but also to develop the capacity across different states or districts of India. So that is the main aim. I mean, in the last 25 years, IPS has developed the capacity in conducting the many large-scale survey like DLHS, LASI, GYTS, and NFHS is one of it. So now, so our plan is NFHS 5 and 6 is not to develop the, but we can develop the capacity of students across the different university. So in that sense, you are planning to conduct the workshop at the university level also. So now if you look at the from NFHS 1 to 5, in the NFHS 1, the estimates at the national level or at the state level. So that's why around 88 or 89,000 households are required, and that is true up to the NFHS 3. But from NFHS 4 onwards, the demand is to provide the estimate at the district level. Some of the important maternal child health indicators, you are providing the estimate at the district level. At that time, there are 640 districts are there in census 2011 frame. So using that frame, we have provided the estimates for all the 640 districts. And at that time, the sample size has been increased of the 6 times of the previous round NFHS 3. So around 6 lakh households are required at that time in NFHS 4. In NFHS 5 is in line with the NFHS 4, but the number of districts has been increased from 640 to 707 districts. There is some cutoff date is there. Accordingly, we have provided the estimate in NFHS 5 for all for 707 districts. Now I think around more than 740 districts are there. So now there are different types of questionnaire is there from up to NFHS 1 and 2. There is a household women questionnaire and village or community level questionnaire is there. That is what type of facility village has. So the detail. But from NFHS 3 onwards, because of the HIV, that that village questionnaire has been dropped. But we have introduced the men questionnaire, and also you are asking for all the women. Means it also includes the never married women, whereas in the earlier round it is only for the ever married women. Now for all the women aged 50 to 49, we have conducted the survey from NFHS 3 onwards. So in NFHS 5 also the same women aged 50 to 49 irrespective of marital status, and men aged 50 to 54. And also you have introduced the biomarker from from NFHS 4 onwards, and maybe I will go through in detail in the later on. So approach was that like DLHS and AHS, so it is every 3 years the NFHS will be conducted. 4 and 5 has been finished, and now 6 is almost planning is in the final phase, and 6 will start from the next year onwards. Maybe from January 2023, the survey will start for NFHS 6. And 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 if you look at the to control the non-sampling error, there are two major approaches we have adopted. One is the district module, and another one is the state module. So state module means the longer version of questionnaire, and district module means up to the section 7 in NFHS 4 and 5 up to section 7. This questionnaire has been canvassed only in the district module. But in the state module, in addition to the section 7, you have also asked question 8, 9, 10, 11, and man. And some devious also has been collected in the state module household only. So like domestic violence, sexual life. So these are the questions has been asked only in the state module, not only in district module. Again, you keep in mind that this district module is the subset of the state module, where first you have asked up to the section 7, then if particular household has been selected for the state module, then you have asked question of section 8 to the up to the maybe 11 or 12 sections are there. So and then main question are also has been canvassed along with devious has been collected. So this that's why then you have to take care of while analyzing the data these two concepts, because sometimes like women's employment and their husband employment, this question has been asked only in the state module. So if you are try to analyze at the data by taking the district module, then that information would be the missing, that is the system missing. So you have to take care of while analyzing the data in district module versus state module. And DBS has been collected in NFHS 5 by dividing the states low and high malaria endemic state, and in the high malaria maybe this northeastern states and I think Jharkhand, Odisha, Chhattisgarh. So these are the states come in the high. So where the all the PSU which are in the district module, there the question has been canvassed. All this DBS has been collected. Otherwise, only 5% PSU have been selected for the DBS. So there are three types of filters are there. But anyhow, this too. So this is the protocols you are following. Whatever the all the ethical protocols are followed, including informed consent, and whatever the question are designed, everything has been done as per the standard protocol. So you are following all this one. Maybe appropriate disposal of DBS, waste management, everything you are doing as per the protocol. So now, if you look at the first one, what is the sample size and design of an FHS survey, and that will be very important to understand everyone before analyzing the any any type of survey, including an FHS. So if you look at the determination of sample size, is you are using this coefficient of variation formula. N is equal to 1 upon alpha square q by p into d. P is the prevalence of the characteristics which you are going to study. Here ANC 3 plus. So you have taken the because pregnant women would be the least in our sample, and as you know that fertility has been declining, so you will get the very less number of pregnant women in the last 3 years or last 5 years from date of the survey. So taking care of, so you have taken the ANC 3 plus visit, which is the indicator of uh, uh, pregnant women. So you have taken this ANC 3 plus to compute the sample size. So now, since this is the prevalence based formula, so where the prevalence would be the low, sample size would be the maximum. So yeah, taking care of this one, you have taken the Bihar, which has a lowest ANC 3 plus visit according to NFHS 4, that was around 27%. So taking P as a 0.27, then Q will be the 1 minus P, and then that alpha is the coefficient of variation. So this coefficient of variation you have kept as a 5%, or sometime 10% also you have taken care of this. So this alpha is the you have kept as a 10%. This is the coefficient of variation. So now this is the 10% and P is the 27% and Q is on minus P, and you have taken also the design effect, which is around 1.2, and this design effect has come into picture that from each village you are selecting 22 household. So this 22 household would be the similar in some of the aspects of NC3 plus, because there is a chance that if a particular woman of a household is visiting the for antenatal care, so chances are there that another woman from the same household will visit the ANC care. So that's why, taking care of that correlation into account, we have taken the design effect of 1.2, and around after taking this one, we have computed the sample size. So we found that almost 725 households are required. But again, with the help of these 725 households, you are trying to compute the full immunization and also the prevalence of stunting, because these are the very important indicator, and you are trying to control the relative standard error of this indicator below 20%, at least in the range of 10 to 15% in NFHS 5. So then ultimate you have decided that it is the 900 households should be required from the state of Arunachal Pradesh, Bihar, Jharkhand, Madhya Pradesh, Rajasthan, Uttar Pradesh, and Uttarakhand, and maybe some other. So these are the states where 900 households should be required to provide the estimates of ANC 3 plus at the district level. So, and for another group of states, we need a different sample size. So, for example, if you look at the Bihar in NFHS 5, there are maybe 39 districts are there in the Bihar. So if you look at the Araya, there are 45 PSU has been decided to select from the Araya district. So according to proportion of rural urban, we have divided in the rural and urban. So 3 is urban and 42 PSU are required in the rural area. PSU means village in the rural area and census enumeration block in the urban area. So 45 PSUs are required to provide the estimate at the district level of the ANC 3 plus full immunization and stunting. So these 3, 4, 5 indicators we have taken care of, and along with this, all other indicators could also be provided. And from each PSU or each village, you have selected 20 household. Here it is 20, but you have adjusted the non-response, so around 22 households. So 22 households have been selected from each village, and since there are 45 villages there, so 45 into 22. However, the calculation shows the 45 into 20, so 900. So but it is 45 into 22, and then 30% of 45 PSU will be the 14 or somewhere 13, 14. So then 14 PSU have been selected for the state module, and in the state module you have selected the alternate household for the for the asking the longer version of question now, not like if a PSU A has been selected for the state module, so out of 22, 11 household where the state module questionnaire has been canvassed, and the rest 11 household only up to schedule up to section 7 questionnaire would be canvassed. So this is the list of the districts. So like we have done the allocation across all the districts of the 7 districts of India, that is around 707. So if you look at the estimated number of PSU in NFHS 4, it is around 28,500 PSUs are required. PSU means village and census enumeration block. So and around 10,000 PSUs are required in the state module. And in NFHS 5, the number of PSU have been increased to 30,500, as number of districts also have been increased, and we have also tried to reduce the RSC below 20% in the range of 10 to 15%. And in the state module, the number of PSU is almost remain fixed, and around 9,000. Again, you are trying to do it in NFHS 6, but still it is a very preliminary. In NFHS 6, it is required around 34,000 PSU because of the increase in number of districts, as well as the some indicators which you are interested in that one, and around 10,000 PSUs are required for the district model. Again, this 10,000 is the subset of 33,000. It is not the mutually exclusive. It is not that 33,500 plus 10,100 you add it and then 43,000. No, this 10,000 is the subset of the district model PSUs, and then you are taking the alternate household to provide the state level estimates. So now, if you look at the design of the NFHS, it is quite different from the other survey. So actually, now since you have started to provide at the district level, so you have first stratification is the district. So if, for example, UP has a 71 or 75 districts, so all the 75 districts will be the first classification. That is the first geographical. After that, after that, once particular district, say Varanasi has been selected, then again it will be divided into two parts, rural and urban area. So within district, the division will be occurred in the rural and urban area. So you are following the different design in the rural and urban area of each district. So design and same design has been implemented for all the rural and urban area of the districts. For example, if you look at the Varanasi districts or any particular district, so the if there are maybe 100 or 200 villages are there, so these 200 villages have been divided into three parts. First part is the collection of smaller village. Second one is the collection of the medium sized villages, and third one is the collection of the villages of larger size. But the condition which we have imposed is that one, the total number of households should be the same for each these three strata. So first we have created the three strata based on the number of villages, size of the villages. So first stratum is the collection of smaller villages, second one is the medium, and third one is the larger one, but the condition is that each 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 stratum should have an equal number of household. So that's why in the first stratum we'll get the more number of villages. Maybe if you say there are 1,000 villages are there in a particular district, so might be 400 villages maybe come in the first stratum, such that their sum of number of household is equal to h, or h might be any value, maybe 10,000, 20,000. So again in the second stratum will be the collection of villages where the sum of the household be equal to h, and again in the third one again some of the households should be equal to the h. So now what would be happen? So after creating these three explicit strata of equal size, where the so that cutoff would be the random in nature. For example, for Prayagraj the cutoff might be from the less than 500 household would be the first, 500 to 1000 in second, and 1000 and above in the third strata. But might be in Varanasi maybe less than 400 would be the first stratum size of village. Maybe less than 400 household would be the first one, 400 household to maybe 800 household in the second, 800 household plus in the third stratum. So I mean to say this cutoff is vary from one district to another district, but the condition that total number of household, approximately total number of household in each stratum should be remain same, because because you are you are also trying to control the variability. So we assume that if number of household is large, that particular stratum would have a also larger variance, larger variability. So try to control this variability. You have taken care of this size as a one measure. If number of household would be remain same, so you assume that the variability would be also remain same across these three strata. And then what happened after that one? Sometimes village size is less than 300, sometimes village size is more than 300, and it is not advised that if more than 300 household, then you do the mapping and listing of all the household, because once this PSU will be selected by IIPS, so IIPS will send this list of PSU to the field agency who are conducting the survey in a particular state. So then once you select this, send this list of PSU. So sometimes the size of PSU might be 200, 250, and might be 400 household. So for 400 household, you have to carry out the mapping and listing. So that's why you are doing the process of segmentation. If size of particular village is more than 300, so you have suggested to do the segmentation. You divide the particular village into three equal parts, and then maybe three or more than three parts, and then you select two parts using the PPS or random sampling, and this selection will be carried out by IIPS. Field agency will divide the particular village into 4 or 5 parts, and then that map will be sent by the field agency to IIPS. Then IIPS will select two segments and report to the field agency to carry out the mapping and listing. And all these two selected segments, they will do the complete mapping and listing. So mapping and listing, in the sense that I think most of you are aware about this, mapping and listing means they will visit each and every household, and they will mark their like NFHS 5.1, so NFHS 5.2, like this they will do the marking in a very systematic way, because it is not the at random, but there is certain routes are there. They have to go first in the center part of the village, and they will follow the anti-clockwise movement, and then do the complete mapping and listing process. It is not in a random kind of thing. So everything is very systematically designed. And sometimes what happened, the size of village would be the too less. For example, if you look at the Arunachal Pradesh, or in the hilly area of a of this states, Himachal Pradesh and Uttarakhand, will find that the size of particular village is too less. It is might be 20, 10. In Arunachal Pradesh, most of the villages are size is 10, 20, 30. So you are the smaller villages, first you are trying to exclude it, but the exclusion is such that their contributions should not exceed the 1% of the total rural population if you are doing in the rural area, or overall it is should not be the 1% of the district population. So that condition is remain you are imposing. After that, in Arunachal Pradesh, you are getting many villages where size is less than 40 or 30. So you are trying to link that villages. So smaller villages you are trying to link, and then you are creating one bigger villages where the size is more than 40 or more than 40, because you have to select at least 20 household. So it is advised that at least double household should be there in the frame. So you are doing this linking process also, and then you are doing then you are creating these three explicit data as discussed. So if you have any question, then let me know. So now after that one, each statum would be arranged by percentage of SC/ST population and female literacy rate. So along with these two indicator, we have try to arrange the each stratum. Again, you keep in mind that since we cannot sort the each stratum by two continuous values, so first one, percentage of SC/ST you have taken the in a categorical form, and then literacy rate you have taken in a continuous form, because it is suggested that literacy rate is the much more important uh, to alter the demographic factor than caste, because if women are educated, so their behavior will be completely different than uneducated women. That's why the female literacy rate has been taken in a continuous scale, and percentage of SC/ST has been taken in the categorical scale. Again, each stratum has been divided into two parts based on the percentage of SC/ST, such that each part should have an equal number of household, and then again each part would be arranged by the ascending descending order of female literacy rate. So 3 into 2, 6 sub part has been created, and each sub part has been arranged by the female literacy rate. So now after doing this one, you are using the PPS sampling, and with the help of PPS sampling, you are selecting the desired number of PSU in each district. So if you look at the Prayagraj, the first stratum, uh, you have classified into two groups. So less than 23.7% percentage of SC/ST population will be the first subpart, and 23 to 99% will be the second part. In a similar way, second stratum, the cutoff point is 25.8, and then 25.8 to 86.9. So like this, you have created this explicit strata. Within explicit, you have do the implicit stratification by percentage of SC/ST and female literacy rate. So if you look at it, these are the village level map for the UP, that is the for total population. And again if you look at the list of selected PSU in Uttar Pradesh, so red one shows the list of selected PSU. So this PSU has been spread across all the parts of the UP, and even within the districts it is spread. It is not that within the district it has been selected from a particular corner, but it is selected and it is spread across all the. So you are doing this verification and comparing that one. So if you look at the so for example, in x-axis is the villages, in y-axis is the size of each village. So each line shows the village, one village is there. So in y-axis is the number of household. For example, some villages are having household 500, some are having 400, some are having 200 also. So these are the list of these are the villages are there, and red one shows the villages have been selected in our sample. But again, you keep in mind that this total number of household in stratum 1 would be equal to the almost in stratum 2. So whatever the total number of household in stratum 2 would be there, so that is the same. So in stratum 2, start from the where is the first one is the highest. So first one is the 500 or 510. So here the size start from the 510 onwards, 510 to less than 1200 household. The villages are such that where their size is more than 510 or 50, but less than 1200, and these are the selected. And second one starts from the third stratum start from the 1200 and above, although it is not there, and then you are doing this one. In the urban area, actually, RGI has given this census enumeration block list of CEB, and for the information they have provided only for the percentage of SC/ST. So what happened for each urban area of a particular district, you have arranged the CEB by percentage of SC/ST population. Just you have sorted the frame in the ascending order of percentage of SC/ST, and then you have selected the desired number of PSU by PPS sampling, probability proportional to size sampling, and then you are doing this one in the urban area. And then another important aspect is the sampling weight. So because just you are selecting the some you are selecting the sample. If you look at the in UP, there are maybe around 96,000 villages are there, where the some one or two households are there. So there are 96,000 households are there, and out of 96,000 households, you are selecting only 45 into 75 PSU. So almost you are selecting maybe 1400 or 1500 PSU, might be more than that, or maybe more than 2000. So based on this 2000 PSU, you are trying to inform the information of 96,000 PSU. So then you have to make it this one. You have to make a this weight is very important. Means you have to compute the weight such that each sample should be equal to the some number of in the population. So that if you are, for example, in a particular district, if there are 1000 households are there, and then you are selecting only 100 households, so each household should be equated such that that 100 household should be equal to the 1000 household of the population. So that's why that weight has come into the picture, and then weight has been come because also that how you are trying to draw the sample. So that is also a very important one. And here you are selecting the PSU by probability proportional to size sampling. And once village has been selected, you are doing the complete mapping and listing. And if more than 300, you are doing the segmentation. And after that mapping and listing, you are selecting the 20 or 22 household using systematic sampling. So whatever the sampling procedure you are adopting, that need to be converted in the weight form. And you are computing the variance using the Taylor series expansion. Maybe I'm not going very detailed. So just for your example purpose, maybe I have taken one example, but to understand the weight, for example, if say in Prayagraj there are total say 9 villages are there in a particular stratum 1. So this is the example of a particular stratum 1. Same will be implemented for stratum 2 and 3. So in a particular stratum 1, say 9 villages are there, and their number of household has been given. For example, village number 1, say any name of village, or any village number 1, the number of household is 100. Village number 2, the number of household is 200. Like this, village number 9 has a 1000 households. So some of the household of villages of 9 villages are 5000. So some of the household in a particular state of 9 villages, and their total is 5000. So 5000 households are there. Now if you say you wanted to select only three villages, say village number 2, 4 and 7. So if you have planned to select only 3 villages, and for example, say village number 2, 4 and 7 have been selected. So now, now the design is that how you select these 2, 4 and 7, there some of the households should be equal to the 5000. If you compute the design weight in such a way, in such a very systematic way, and you design your study, the beauty is that you design your study in such a way that once any 3 villages have been selected, and their sum of households should be equal to 5,000, and that is not possible. If you look at the say village number 2, 4, and 7 have been selected, and then from each village, as in NFHS, you are selecting 20 household. So 20 plus 20 plus 20, so only 60 household have been selected. But this, but the idea is that you design in such a way and compute the weight such that this 20 into weight plus 20 into another weight plus 20 into weight should be equal to 5,000. This 60 household should be closer to the 5,000 after applying the weight. I mean to say, once you compute the weight and apply it, then this 60,000 together will represent the 5,000 household. That's why sometimes say your survey or your design is representative or not. It means that whatever the variability is there in your population, that should be captured. Along with that one, another important dimension is that weight computation. So that these three villages which you have selected out of 9 should represent the 5,000 household. So that's why the idea and everything, there are many different types of design is there. There are many different ways one can do it. But whatever adopted in NFHS is that you are selecting the PPS sampling. But after selecting the PPS sampling, you are selecting the 20 household, and this 20 household has been fixed because it is a it is a it is it is a very logistic also. I cannot say ki for a particular field agency go village number A and select 20 household, go village number B, select 60 household. For example, if you look at the village number 1 to 9, the size of village number 9 is 1,000, whereas the size of village number 1 is 100 household. But in both the villages, in an NFHS, you are selecting 20 household. But it is not at all logical because the village number 9 is very large, having 1,000 household. Village number 1 having 100 household. So why you are doing that like this one? You are doing like this one because there are a lot of difficulties will come in the field. How to manage that one? If field agency should go in the village number 1 and select 20 household, and go in village number 9 select for example say 60 household. It is not possible for the field agency because they have to increase the number of days also. Maybe their number of teams are, they have to increase the number of teams. And since in the survey you are fixing one vehicle, and the strength of vehicle is the maybe 8 or 9 seater, so maximum 8 and 9 people would be there. So you are fixing the number of days for every village. So but number of days will get changed. So for village number 1 they have to spend only 3 days. For village number 9, they have, where 60 household have been selected, they have to spend maybe might be 7 or 8 days. So there's a lot of practical difficulties are there. So to get rid of this difficulty, number of household in each village have been fixed, that is 20. And then what happens once you fix this number of villages, then you have to change your design. Then what design has been selected, that you select the villages by PPS sampling, probability proportional to size. Means you select the, if you are planning to select 3 villages out of 9, then you don't give equal chance to all the 9 villages. You give to the higher chance to those villages which are having higher number of household, and low chance to those villages which are having lower number of household, and then you can fix the number of household. Otherwise, if you are doing by the SRS, then also you have to do the proportional allocation by the household level, which is very difficult as discussed. That's why our design is that one. First, you select the villages by PPS. Once after selecting the PPS, you fix the number of household 20 from each village. So that is the formula, and you are deriving this one. So ultimate, what would be the probability? Probability, for example, if village number 1 has been selected, so the probability of selecting this village is the how many villages you are selecting. So you, in the state of 1 you are selecting 3 villages, for example. So 3 into 100 divided by 5,000. Otherwise it will be simply 100 divided by 5,000 if you are doing the SRS. But since you are doing the PPS, so there is a derivation. So that there is any, you can find any standard book. So that it shows that number of villages to be sampled into size of that particular village divided by total number of household in that particular stratum. For example, if village number 9 have been selected, so since you are planning to select 3 villages from this particular stratum, so 3 into 1000 divided by 5000. So that is the probability. So I don't know, is it okay for everyone or maybe is it okay? You are
Yes, many are from technical background, but it's always good to understand the sampling frame and sampling design before doing applying weights or any kind of survey analysis. So I think it was really good, sir. So please go ahead, no problem. Any student if had any doubt till this stage, they can ask. Otherwise, in the end of the lecture, they can ask.
okay. Okay, thank you, Dr.
Yes.
Thank you.
Yes.
Okay, like this, one can do it, and I'm not doing the derivation. So, but one can find out like there are three into 200 divided by 5000, 3 into 400. For example, village number 2, village number 4, and village number 7 have been selected. You can compute the probability, and then since you are selecting 40 household in this example, so 3 by 25 selecting into 40 divided by the size of that particular village, so you can make out means ultimate the probability would be remain same, and so that's why it is known as the self-weighted design. If you reverse it, then this one by this example even maybe now here it is not possible, but in this example I used to show that if you multiply the weight by number of household have been selected, because here 3 villages have been selected, and from each village 40 household has been selected, and we have computed the weight is 125 by 3. So if you multiply, it will go to the 5000. That is the total number of household in the frame. So one can actually do it. Maybe if you look at their total 5000 households are there, and out of 9 you have selected 3 by PPS, and if you derive the weight everything as given in any textbook, so that is the weight is 125 by 3 for each PSU. So 125 by 3 into 40 plus 125 by 3 into 40, if you multiply, you will get the exact 5000. Means for each household carry the weight of 125 by 3, means around 42 times. Each household represent the information of 42 household in the frame. You have selected only one household, but the information of one household, whatever is there, it is equal to the 42 household in the frame. And that is the concept of the weight. And maybe one can, if they want, they can refer, or it is there in the NFHS report also, but that is the meaning of generating the weight. Now one can also adjust the non-response in a particular village. Only out of 20 household, only 50 has tried to answer the question, 5 household have refused. So that non-response should be adjusted, because now this 15 is equal to the total number of household in the frame. You are getting my point? So this 15 will represent that one. So this non-response also would be adjusted, but you are adjusting the non-response at the stratum level, not at the village level, because you are thinking that stratum is a one homogeneous unit, and you are adjusting the stratum weight at the stratum level. That is a non-response, and you are doing like this one normalization of weight and everything. Maybe this is much important in the one-to-one session, but one can do it also. This is another example. If you adopt different method, then you have to do it in a different way. Maybe so that's why the procedure would get different. So it is not necessary that whatever NFHS propose one can adopt it, but if you are adopting any approach, the basic idea is that one, the total number of household sample should be equal to the total number of household in the population. Then only you can provide the estimate which is reliable. Otherwise your estimate will be the biased one. That is the any theoretical, any statistics book suggests that one. So this is all about the weight, and then again weight is the so self-weighting design means each village or each one has a equal weight, and if there is no non-response, so by self-weighting means that weight will be equal to the one, means there is no need to assign the weight. but actually it never happens. So that is the concept of normalization has been occur. But what I would like to highlight here, that one of the important point is that one, you look at weight has been computed at the PSU level, means at the village level in the rural area, and census enumeration block at the urban area. So all the weights should be at the PSU level. Weight cannot be at the national level, cannot be at the state level, or it cannot be at the district level. But sometime in the data file you will get the weight at the state level, weight at the national level, but both are equal. Only the normalization has been taken place at the state level for the state level weight, and at the national level for at the national level weight. I mean to say, once you apply this weight, then your total weighted sample should be equal to the total unweighted sample. That is the meaning of normalization. So normalization is nothing but the standardization in a such a way that total weighted sample should be equal to the total unweighted sample. But again, there is one can apply any weight anywhere, but only the idea is that if normalization has been taken at the state level, so you cannot apply this weight. For example, if normalization has been taken place for a particular state of Uttar Pradesh, then that weight you cannot apply it for the Bihar. So for Bihar, you have to look at their normalization which has been taken place at the Bihar level. So that's why if you generally apply the weight of the national level where the normalization has been taken at the national level, then it will be the okay. For example, those who have used the NSSO data, in NSSO data there is no such normalization, so they have given only one weight. There is no concept of state and national weight, and actually there is no concept like this ki national weight versus state weight. This is just a way how you have done the normalization. Since they are not doing the normalization, so their one household represent the maybe 1,000 household in the population. So that's why you will get the denominator will be the total number of household in India if you are analyzing at the India level. Here in NFHS, since number is very big, so that's why they are trying to adjust that one. They are trying to normalize that one such that before and after normalization, the weight, the sample size will be remain same. Otherwise, there is nothing one. But again, if normalization has been taking place at the higher level, then weight can be applied at the lower level. For example, that national level weight can be applied for any state anywhere. So no need to touch the state level weight. Just you apply, it will be okay. The only difference is that you will not get the total weighted sample is equal to total unweighted sample. For unweighted sample, you have to off the weight and then run the analysis. Otherwise, there is no meaning. So high level weight can be applied at the lower level. So there is no issue at that one. So that's why generally you are using at the national level weight and you are doing all the analysis. So you will, otherwise, if it is like that one, then you have to do the normalization at the district level, because this is the district level survey. So for all the 707 districts, you have to generate the 707 weight for the household, 707 weight for the women level. So there is a huge variable should be there in the data set. So our whole data analysis, everything will be too slow. So you need, so that's why there is we have not given the normalized weight at the district level. Uh, just we have provided at the state level, but actually national level weight, whatever is given in data set, it will work. And again, I wanted to highlight that as such concept of state and national level weight. Just you have to adjust you have to compute the weight at the PSU level, whatever the PSU probability into probability of selecting the household. If non-response is there in the household, then you have to adjust, and that household is the household weight. And if you are adjusting the non-response at the women level, then it will be known as the women weight. And if you adjust the non-response by HIV prevalence, because then it will be the HIV weight. Otherwise, there's nothing new. For example, in the domestic violence, you are selecting only one woman. You are not selecting all the women. If you are selecting all the women, for example, in a household there are 3 women are there, and you are selecting all the women, so 3 by 3 equal to 1. But for domestic violence, there is some other issues are there. For this, you are selecting only one woman. So out of 4, only one woman are selecting, so equal to 1 by 4. So that's why for domestic violence, you have a separate weight. Otherwise there's only one weight will work. But for HIV, there's a very high non-response and very sensitive indicators are there. So you have adjusted the non-response at the for the HIV. How many tests has been conducted? What is the how many have ready to give their blood, and after blood how many samples have been wasted. So everything has been taken care of to compute the weight at the HIV level. Sometimes people are pulling the two round of survey, like NFHS 3 and 4, they can, or 4 and 5, they can pull and done the survey. But while pulling the survey, you cannot apply any weight, because pulling the survey, then you have to do the normalization at the pool data. But since normalization had been done at the national level for a particular time period T1, and again for a different time period T2, so you cannot do this. You cannot apply any weight. So now what you have to do? You have to do the denormalize the weight. Means whatever what NSSO does, provides the weight, you have to compute that weight by doing the denormalization for each round of survey. So normalization is nothing but you are doing summation Ni upon summation Wi. So total sampled total sampled household divided by total weighted sample, means total weighted sample means total number of household in the frame. So that normalization maybe you have to do this denormalization, and then you can pull the data and apply the weight. So maybe in the data usually you are doing this one, some type of command. You are dividing by one. I think after one there's 60. That is 1 million. So that is only just because they are not entering the weight in the point 0.85656 like this. So in place of point, it is written as a 85656. So you have to divide by this one to get the 0.8565, because the entry of 0.85 every time would be the tough. So that's why maybe they have made this one. But that one can generate the weight, and then again, so the survey, the important one, what I would like to, once you are computing any confidence interval of this survey set, that is the name of the PSU V021 in data, and you have to P weight or whatever you have, the P weight is the V0, data is V02. This command is required if you are providing any estimates like standard error or confidence interval. It is not like just like a proportion command and you provide a confidence interval. In that sense, it will assume that your design is the SRS. But if you set like this one, then it will take care of your PSU cluster effect and your statum, whatever the advantage you will get because of stratification, and then weight, whatever the loss and gain you are getting by applying the weight based on the non-response. So this command is very much important in before doing any type of analysis. So these are some commands are there. Maybe you are familiar. Just I would like to highlight that don't just like a proportion religion and then give the confidence interval or proportion in ANC 4 plus. So that will be the confidence interval is based on the SRS sampling, and SRS. So you are not adopting the SRS, you are adopting the two-stage, maybe sometimes three-stage sampling design once village has been segmented. Otherwise, it is a two-stage, once village and then household you are selecting. So maybe two or three stage you are adopting. So this stage should be adjusted, and that has been adjusted in the V0, that in the weight file and also in the statum. So statum and weight has been given in the data set, and then you can apply and compute all the indicators, whatever by doing whatever you are interested in analyzing. So so the weight value is V05 for household and person file, it is HV05 for women and children. Already V05 is there. But if you are doing the couple file, maybe now they are DHS, they are trying to compute the weight. There are different methods are there. Maybe Steinbecker has given that method. But in NFHS generally, it is better to apply the weight whatever has been given in the man file, because man response rate is the lower than the women. Women response rate is always higher side. So apply that man weight, because you are merging this couple file. So you apply the man weight and then analyze the data. So there are domestic violence, HIV testing already I have discussed. So there one can do it. Maybe more. These are the YouTube one can get from the YouTube, and from this data you can understand more properly. Now, sometimes this is also the, maybe I'm leaving this one. Sometimes slum estimates are a problem, creates the problem in NFHS, and you are, because this sampling frame you are not getting from the census, you are getting from some different source, like in state, city specific municipal corporation, and then it has some advantage. I mean to say, once your frame is not very updated, sometimes will create a problem also. So it's okay. So this is the, actually, just briefly I will explain how this data has been processed. So first, IIPS is the central office. So IIPS send the list of PSU to field agency. Field agency will send the that particular list to the supervisor. In each team there is one supervisor, three female investigator, two health investigator, one male investigator. So there are seven teams are there, including diver. There are eight people are there for each team. So once IPS will send to field agency, they will share the data in the supervisor, and supervisor each PSU, for each IPS will give the list of PSU for a particular district only. It's not that for all the UP the list of PSU will be selected. No, only for first survey will be conducted only 2 or 3 districts only. So IPS will share that PSU, and then they will assign the supervisor which team they will work. And before assigning, they will send the team number. This particular team number will work in this team, in this PSU, and that list will be shared to the IIPS. IIPS knows in advance that which team is going in which particular PSU. So that's why then supervisor will assign the household to the interviewer. So they will finish the interviewer. Then interviewer will share the data after completing the survey to the supervisor. Supervisor do the secondary editing and then sync the data. Once it will sync, it will automatically go to the IPS. Field agency is, there is nothing, any server. Field agency is just a monitor setup. Otherwise, IPS directly do assign the that PSU to supervisor. Supervisor will assign to the interviewer. Once interviewer and supervisor will agree that the survey has been conducted, there is no problems are there, then they will sync to the IIPS. So there is a paradigm shift in data collection. I am not going very in detail now. NFHS3 is the paper pencil, and you have shifted to the KP program. So KP has many advantages along with some of the disadvantages, but their advantages are too much than compared to the paper pencil. So and so there is, everything has been secure. Internet file stripping system is there. IFSS system is there. So already, so this is the assigned to interviewer already. Maybe you have just missed this one. So now, so these are the workflow here. So I'm not going very detailed. So like this, it is the work for all flow is the, so assign to PSU, open the PSU, then supervisor give the assignment, keep particular females go in this particular household, particular female, they will conduct it. Then they will sync to the supervisor, do the secondary editing if required, and if there inconsistencies are there, they will visit and complete the survey. So IPS will monitor the just what are the mechanism are there to control the non-sampling error. So so once survey of 2 PSU have been conducted, you are doing the debriefing session. Earlier you are going in the field, and then now in the, but now because of this online platform, you are conducting this debriefing session and explaining their where they have made some error of this one. So I mean to say, these are the supervisor level corrections. So they are doing. So they are field check table. These are the one other important tool, that is a real time data access. So once they will complete the PSU, we will get the data, and then we will generate the table. Based on this table, we will give the feedback to each and every female investigator, female, male, and health investigator, where they are committing the error. That is the one of the great advantage of using the KP programming. So once this, for example, this you can go at the individual level, not by the state level. I am showing by the state level only, but within the state I can go for each team ki how many vigils she has made. If many people are completing the survey in only one visit, then it creates the problem. It creates the problem about the data quality. So then you are we are giving the instruction ki why, how come you are completing all the survey in one visit. So there are multiple visits are required. So sometimes multiple visits has an advantage also, disadvantage also, but it is very obvious that no one can finish the survey in one visit. So you are making the control this one. What is the response rate is there? If the response rate is too low or too high, it both create a problem. If the response rate is too high, then definitely there is some problem, and it is too low after, then so then you are managing that one by looking the response rate, by women response rate, men response rate. And sometimes, because in NFHS, the age of women is there 15 to 49. That is the eligible age is there. So what happens, the investigator try to displace the age. Women who are age 15, that particular investigator report that no, her age is 14 or 13, to reduce the workload. That is a very common phenomena everywhere. It is prevalent. So now, so you can generate this type of table by team wise, even within team, by investigator wise. You will generate the table, and you will find out which particular investigator in which particular district, see, or in particular PSU, they are displacing the age. So age displacement can be captured by the generating this table. This field check table is a very important tool to control the quality of data, or it has improved the data quality much better. So now even cutoff age also in the ending 49, 50. So those women who are 48, 49, they will report to the 50 or 51. So now one can look at this table. This is a real data for a particular Andhra Pradesh. So maybe particular team 101. Even I can click 101, and then I can say which investigator are committing more error. So I can find out this one. So like this birth displacement also, that is one of the important one, is that you are collecting the large number of information based on the birth which has been taken place in the last 5 years from date of the survey. So what happened if you are collecting the information from 2012 onwards? So they will displace the birth in the 2011 or 2010 to reduce their workload. So that type of problem we found. So, so like this percentage of children reported to have a vaccination health card, and how many investigators have seen this health card? Because if you collect the information from the health card, it is a tremendous advantage than asking the immunization, different types of immunization based on the recall. So if you ask women, maybe sometimes she forget or she could not answer. But now you know that from the HMIS and other data that most of the women have a vaccination card. Even in UP also they have. So that why not the information should be collected from the health card. So you are looking at how many investigators have tried to see the vaccination card, but you found that because of this field check table, now if you analyze the NFHS 5 data, almost 89 and 89% information of immunization have been collected in the vaccination, have been collected from the card. And now, so our immunization data is more reliable than many other parameters. So it shows a tremendous improvement because of this card only, and this field check table help a lot. So like this, I have given this one. It just for not interview in the privacy. So if you interview has been conducted in the privacy, so it is a good one. But if it is not conducted, then how many interview has been terminated? You can get this information. And some of the skipping, if you can skip some of the question, maybe birth has been delivered in an institution, but that particular investigator selected the home. So because of home, there are so many questions would be the miss. So this type of skipping, some of the important indicator we have chosen, where there is a large number of skipping is there, and based on this one, you have tried to control the data, you have improved the data. So I mean to say there may biomarker also you have collected. So, and again, project officer query report, our PO will be there in the field, and they have all the, they can generate the indicator in their mobile phone, and which no one can generate it, and they will go and they will find out PSU wise where is the problem. If somewhere, and they might be sometime they will conduct the resurvey, but resurvey of the general question, not the very sensitive question, very general question. They will conduct the resurvey and match it. So these are the POQR report is there. So many schemes are there in NFHS. Just I thought I will convey. So field team composition. Look at this team 112, by which investigator are creating the problem. So we are getting this one. This the, sometimes you are computing people index also, for which state there is a problem for heaping on what is the response rate. Like this, there are so many indicators one can compute it. Birth year ratio, displacement of birth, children proportion card see. And another important one is the tab 1 in NFHS 4-5. You have collected the clinical, anthropometric, and biochemical components in NFHS. For example, NFHS 4, under 5-year children, you are taking height, length, weight, and anemia testing. For women, also 15 to 49, and also height and weight you are also taking for the women. DBS collection for HIV testing, and this DBS collection for HIV testing is not there in NFHS 5, but it is there in NFHS 4. Now it will be in NFHS 6. Blood pressure you are taking age group 15 to 49, but in NFHS 5 you are taking from all the uh, person from aged 15 years and above. And random blood glucose here 15 to 49, but here all the person salt testing. So now same, but here you have taken hip and waist circumference also, and you have collected a DBS for HbA1c, vitamin D3, and malaria parasite and anti-malaria drug resistance. So this DBS you have collected for these three, but that will be the data is not in the public domain. Still the testing is going on, that ICMR will conduct the test. Otherwise all other biomarkers data is in there in the public domain now. So now this is the which women has been collected. So I have already explained. So weight and height you are from 0 to 71 means one under 5 children and men. So already I have explained this one. Cap test you are using the, what are the infantometer, stadiometer. So these are the very standardized protocol is there. So you are doing this one. I'm not going very detailed. So stadiometer, infantometer, children of less than 24 months or less than 85 centimeter. So you are using infantometer, and that digital scale for the weight, where maybe it's more better than the any other different type of instrument. The cost might be the 50,000 for this weight measurement like this. So I'm not going very detailed. So one can, so you are doing the anemia and this hemoq photometer. So this sometime it creates a issue also, because you are doing capillary blood. So maybe 320. So there are many is there. So just I am missing. So, but there are certain procedures are there, like blood you are selecting. So first it is wipe out, and then second also you are not taking for the children. Third drop would be used for anemia, and fourth one will be collecting the DBS. For women, first you are not taking for any, and then second drop you are using for blood glucose. Third one for anemia. Fourth one DBS. Fifth and sixth DBS. So they are important is there. So now maybe uh, can can I take 5 more minutes, Dr. Kunal?
Yes, yes, sir. Yes, sir.
Okay, thank you. So just within a, so although these are all the important findings are there in the public domain, just briefly, maybe there are many slides are there. I will not cover this one. So if you look at the full immunization, so how from NFHS 1 to 4 it has been increased. So the main, another important factor for this increase is the vaccination
Shivani,
card.
please
Now,
unmute yourself because
if you
disturbance
collect
are
the
Shivani, please unmute yourself.
if you collect the information from the
Shivani,
recall method, might be it will not appropriate. Maybe in many that mission in Dhanush and other programs are there. It played a major role, but the information are now more reliable because of you are collecting the to the vaccination card. So now, if you compare the NFHS and 4-5, so in NFHS 4, only 15% districts are there. The percentage of immunization in the range of 80 to 95%. But in NFHS 5, almost 52% districts are there where the full immunization is in the range of 80 to 95%. So one can look at, one can go at the village, at the district level and can identify. For example, UP, there are 9 districts are there where the full immunization is too low. One can identify and do the sum. So this the children breastfeed within 1 hour of birth. So it is almost remain same. So there is so much argument is there. Might be it is the because of rise in C-section. So it might create a problem with the rise in C-section and exclusive breastfeeding, although it has showed the improvement in India. And diarrhea in my children might be so one can make it the graph and look at the how this pattern has been changed during NFHS 4 and 5 or the prevalence of diarrhea, which are the regions where less than 5%. Sometimes the month of interview also makes a difference in the rise in diarrhea. And look at the stunting, this one, this stunting, the percentage has been declined from 38 to 36% in India level, and from rural area 41 to 37, and in the urban area almost remains same. There's a lot of argument is there. So we have computed this confidence interval whether for which particular state the prevalence has been increased. For example, if you look at the Bihar, it is from 48 to 43%. There is a significant, because the confidence interval does not overlap to each other. So for Bihar, there is a significant decline in the prevalence of stunting. However, the level of stunting is too high in NFHS 4. Likewise, for example, in the Goa, there is no significant difference because CI overlaps. So one can look at this and find out where there is a significant increase, or for example, in the Jharkhand from 45 to 40%. So there is a major improvement has been observed in some of the states. However, like this, one can analyze by this stunting by state and where there is improvement by district. So one can do the uh, right? But if you look at there are almost 130 districts are there out of 640. 130 districts are there where percentage of stunting is in the range of 45 to 60%. But in NFHS 5, there is only 71 districts are there. But it doesn't mean that stunting has been improved a lot. There is much more work is required in this direction. But still, one can identify which districts are major issue. In UP, there are 48 districts where it is range of 30 to 45 districts. One can identify and work on this one. Maybe wasting is the this is the RT, but one can look at like this one. So many analysis we have done highly open, so one can make it this type of analysis, overweight, double burden of disease. There are many scopes are there. I think you are familiar about data set, but there are many other topics is there. One can do the research of double burden of malnutrition among children, mother are stunted. So now if you look at the bio wealth index, they are behaving in a different way. Like the poorest people are having still the problem of underweight, and where their mother is underweight and child is underweight. But the wealthier, richest people are having different type of problem where their children is having is overweight and mother is overweight. So this type of different scenario is there. One can do the analysis of anemia also, but the anemia has some measurement. So one can look at this anemia. So there are many other. If you look at this neonatal mortality, which has been improved a lot in NFHS 4 it was 30, now it has been declined to 25. But if you look at the state specific, so you will find the major change. For example, if you look at the Uttar Pradesh, it was around 45 per thousand live birth in NFHS 4. But in NFHS 5, it has been declined to the level of 36. There is a remarkable improvement has been occurred. Maybe more improvement is required. But if you look at from 45 to 36, and in Uttarakhand also, or in other region also, there is some improvement has been observed. But there is more. If you wanted to reduce the infant mortality, more work is required in case of neonatal, because the contribution of neonatal to infant mortality rate is around 70 to 75%. So almost 75% deaths are occur in the within 28 days. So so there is more required in this one. So this is the CI, whether there is a significant or not significant, where is a significant decline. This is the IMR. So like this is there. So now I have completed thank you. If you have any question, you can ask. Thank you very much for listening.
Yes, thank you, sir. Participants, please ask questions. Then I will have also some. I will ask some questions. But first, participants, please ask any doubts. Um, Before this lecture, I have shared the YouTube links of like instruction providing the how to download DHS datasets, how to register. These screenshot I have already shared with participants, and also I have shared the India report and UP report with them, so that they can have at least some acquaintance with data. So participants, please ask if any of you have worked on NFHS data. You have more questions. If you have not worked still, you can ask how to access these things, how to apply weight and all. Please feel free to ask. Some of IIPS students are also here. They have also joined. So participants, please. So Dr. Ravi Kumar, can you hear me, Dr. Ravi Kumar? So then I will ask something for my understanding or for my students also, because some of my students are working on NFHS 4 and 5. So sir, two things, like we have two weights, at least three weights, but for India weight and state weight I am asking. I hope I am audible. Hello? हेलो, मेरी आवाज आ रही है? हेलो,
हाँ हाँ, आपका आवाज आ रहा है सर.
Yeah, you are able to.
अच्छा, थैंक यू. So, Lakshmikant sir, I just want to ask, suppose we are doing any district level analysis for the UP, so which state we have to use? Only for UP?
For UP, if you are doing the district level analysis, so either you can apply the national level weight or you can apply the state level weight. Because if normalization has been taken place at the higher level, you can apply at the lower level. So either one you can apply. Better to apply the national level weight. There is no problem.
Okay. So suppose I have to compare Chhattisgarh and UP immunization or neonatal mortality, anything. So which weight we have to use, national weight or state weight?
Then you have to apply only the national weight. National. And for district level estimate, you apply the national weight and compare the estimates of UP and Chhattisgarh.
Okay, thank you, sir. One other thing, sometimes students complain that we are not able to match estimates from report. So suppose we have used unweighted sample. Generally, this is the tradition we followed in IIPS period. So for this table matching, I think in tables, if suppose I am matching NFHS 5 data set, some analysis I have done and I want to match with report. So I have to use for the sample matching, unweighted sample, unweighted things.
Yeah. Yeah, unweighted sample you have to match, but I think in the report it is the you have to
हाँ,
check whether now it is the weighted, because if you apply this in a stata IW, then it will match
I
to the weighted sample. Yeah. So
IW weight we have to
but,
use. Okay.
but you should match it before matching this one. Should not analyze that one.
Okay. हाँ
But
हाँ.
now the NFHS 5 has some issue. Maybe after 1 or 2 weeks, we will get the new revised data set. There are certain
Okay.
indicator has a problem. Weight
अच्छा अच्छा.
computation of weight also has been revised.
Okay.
So some of the problems has been examined. So
Mhm.
now we will get the newer version soon.
Okay. So I have given this thing like students can download reports from IIPS website, but if they want to use the raw data, like a data form data or a spaces data, they can go to DHS website and register themselves. वहाँ पे आपको एक लॉगिन मिलेगा और 1-2 दिन बाद आप डेटा डाउनलोड कर सकते हैं. तो as sir is telling कि you can start using that data after 2 or 3 weeks when data will be 1 week or 2 weeks, sir. So these things, these data sets will be uploaded in DHS, no?
Yeah, in DHS website.
Okay. Mhm. Okay. So we have to wait for at least 2 weeks. So we get final data. Okay.
Yeah.
So yeah, it is really a nice presentation,
Sir, I have a
Professor.
question.
Yes, yes, please ask. We are waiting for
Sir,
questions.
in NFSS 5, I analyze the tobacco data. I mean, I'm working on tobacco user. So when I calculate the total tobacco user for India, so I'm getting 39 point something, but it is report it is in 38.92. So there is a point something differences with report and my analysis. So should I continue or?
Maybe sir knows better, so it's no problem. That much difference is okay. It is acceptable, and you can continue.
Oh, okay,
That
sir. Thank you.
that is not the problem at all. But some of the indicators has a major issue, so that need to be rectified. For this is okay.
Okay. So any other question? And weights thing I think have been clarified by sir. Like Neeraj was also asking yesterday. Neeraj is there. Neeraj, you have any question? Neeraj, Dr. Neeraj is giving. So yeah, weight thing has been cleared. So I hope some more students will start using NFHS data, because it is, I think, most important data of Indian socio-economic and health domain, and it is important to use this data because this is, I think, most sample size is also good. We can have now district levels estimates. So very beautifully, Dr. Professor L.K.Dwivedi has begun with introduction of NFHS and cleared the sampling design doubts, and told us about the which weight we have to use. So now I invite Moslem. He is also from IIPS. Means earlier he was in IIPS. Now he is doing PhD. So Moslem, please propose a formal vote of thank. And I request all the participants to stay here. We will have a group photograph after this session. So Muslim, please start.
Thank you so much, sir. Sir, my name is Moslem Hussain. I did my MPS and MPhil from IIPS only. And 2020, I have completed MPhil. Then I joined at Central University of Karnataka as a PhD student at Department of Geography under the supervision of Dr. Shondit Sarkar. So a very good afternoon to all of you, sir. It seems to be a grateful honor to propose the vote of thanks to our speaker of the session, Professor L.K.Dwivedi sir. On behalf of the GB Pant Institute and all the participants of the workshop, I would like to extend my heartfelt gratitude and thanks to Professor Dwivedi sir professor at IIPS Mumbai, for sharing your graceful words with us, sir. Sir, we had an opportunity to hear your significant lecture on National Family Health Survey in details, and I hope this will surely be going to encourage us, and especially for young researchers for their future research career. And sir has highlighted the NFS's data like very significantly about sample size, sample design, survey design, details of sampling weights, and how they select the PSU, and how they collect data, and how they manage the team of the investigator and all things, and about the new addition in the recent survey data, and obviously the crucial findings of the recent NFS's 5 data. Sir, your thought have enlightened our minds and have shown us a new path to work with NFS's data. So thank you so much, sir, for having spread your precious time for all of us. Thank you for being with us, sir. Thank you so much.
Thank you. Thank you for.
Thank you, Muslim, for vote of thank. And I would again thank all the participants and our resource person, Prof.L.K.Dwivedi, for giving a very timely and a good lecture that will enable us, our participants, to use newly released NFHS data. Thank you so much, sir. And we will look forward to collaborate in that sample which you are telling now. Like there will be some workshop on NFHS data users. So I hope it will be in person, and some faculty from IIPS also join us in this when we conduct this kind of workshop. I will start
Yeah,
from
we'll be happy to do that.
yeah, proceeding for that, sir. And I also request all the participants to keep an eye on our website and Facebook page, so that when we will have this full-fledged NFHS workshop, so you can join it. So thank you so much, sir, and hope to meet you
Okay,
soon.
now I can leave now.
Yes, sir. With your kind permission, we will also close this session, sir. Thank
Okay,
you, sir.
thank you.
Thank you, sir.
Thank you.
Sir, can we arrange a photo session?
Yes, I am waiting for that. Yes. Yeah. So all the participants, please switch on your videos so that we will have a group photograph. I hope we have more than 20 participants. Please अपने वीडियो ऑन कर लीजिए. एक ग्रुप फोटोग्राफ आज होगा, एक कल भी 3:30 पे करेंगे. जो लोग बच जाएंगे उन काम करेंगे. सब लोग ऑन करेंगे तभी एक साथ वीडियो लूंगा मैं. Please, all the participants, switch on your videos. Please, all participants. So after a long time, I am looking at Loma ji. Hello, Dr. Loma. So please, all the participants. Hello, Arvind ji. संदीप जी ऑनलाइन है?
यस सर.
सबका फोटोग्राफ एक गैलरी में कैसे ले सकते हैं, एक बार वो एडजस्ट कीजिए.
मैंने अभी एक लिया है, मैं एक और ले रहा हूँ.
हाँ, सबका एक साथ जितने लोग वीडियो ऑन कर रहे हैं सबका एक बार ट्राई कीजिए. सो सारे लोगों ने ऑन नहीं किया है शायद ना?
यस सर, सारे लोगों ने किया है. इसमें केवल 9 पीपल्स हैं वैसे, आपको इंक्लूडिंग.
अच्छा,
मैंने
ये मेरे वाले विंडो में सबका तो नहीं दिख रहा है. कैसे इसकी सेटिंग होती है? अच्छा, गैलरी व्यू है. अभी गैलरी व्यू है.
गैलरी व्यू.
हाँ, खैर आप लोग शॉट ले लीजिए. सारे लोग अब हम लोग क्लिक करने वाले हैं. ठीक है, सब लोग एक साथ आ जाएं प्लीज. प्लीज स्विच ऑन योर वीडियोस. यस, मानिक इज ऑनलाइन. यस, गुड. सारे लोग ऑन कीजिए. अब सब सारे विंडो आ रहे हैं मेरे.
अभी सर सारे लोग.
हाँ, मैंने एक अलग व्यू किया है, मैं शेयर करूंगा। कल फिर 3:30 पे हम लोग ट्राई करते हैं कि मैक्सिमम लोगों की फोटोग्राफ आ जाए हमारे पास। Please be ready for that. Shambhavi is online. I'm looking very good. Dr. Shambhavi has been a resource person earlier for one of our course, and hopefully she will be again. Yes. So, uh, Dr. Deepika has come. Diksha is there. Very good. So, please आप लोग फोटो ले लीजिए, स्क्रीनशॉट कीजिए जल्दी। संदीप जी।
Yes, sir.
Yeah, thank you. Thanks to all of you for coming here, and we will resume this session after 20 minutes. Dr.
Thank you,
Angan,
sir.
he is a assistant professor in Amrita University, Bangalore campus, and he will be telling about extension of this thing, because more technical thing we have learned about NFHS sampling design and all. So how to do any practical application part like health inequality analysis. Okay, so please be ready for that. Thank you so much.
Thank you.
Thanks.
Thank you, sir.
Thank you, sir.